In this video, we want to learn how we can use sum and difference of cubes identity for factoring expressions. These two identities are famous to sum and difference of cubes identities. A to the 3 plus b to the 3 is a plus b times a2 minus ab plus b to the 2. A to the 3 minus b to the 3 is a minus b times by a to the 2 plus ab plus b to the 2. It's not really easy to memorize these identities, but if you want to take advanced courses in math, especially calculus and more advanced courses, you need to memorize these identities for finding limits and other things. The thing that we have noticed in these identities is that when we have plus, in the first bracket we have plus, and if it's minus, in the first bracket we have minus. And in the other bracket, the sign of these two terms is exactly opposite. If here is plus, here we have minus. If here minus, the other one is plus. And the best way to learn identities is not really to memorize them, is to do questions, and by doing questions, gradually you memorize them. The first example here is x to the 3 plus 8. 8 is 2 to the 3, is a cube, is a perfect cube number. 8 is 2 to the 3, so I erase 8 and I replace it with 2 to the 3. Then this exactly is in the form of a to the 3 plus b to the 3. A is x, b is 2. So we can use the identity to factor x to the 3 plus 2 to the 3, and its factored form is a plus b, so x plus 2 times by a to the 2, x to the 2, minus ab, a times b, so x times 2. But never we write x times 2, we write 2x. And finally b to the 2, 2 to the 2, or 4. This is the factored form of x to the 3 plus 8, or 2 to the 3. Look at the next example. A to the 3 minus 1000. 1000 is 10 to the 3. So this is exactly this identity. A to the 3 minus 10, or b to the 3. Based on the identity, the factored form of this is a minus 10, a minus b, a minus 10. A to the 2, so a to the 2. ab, 10 times a, or a times 10, 10a. b to the 2, b is 10, 10 to the 2 is 100. And this is the factored form of this. Look at the next example. 27b to the 3 plus 1. 27b to the 3 is basically like 3b to the 3. We have to write this term in the form of a something, an expression to the 3. 3b is your a, basically, to the power of 3. Now this is in this form, a to the 3. And 1 is 1, 1 to any power is 1, so we can write 1 as 1 to the 3 if you want. So plus 1 to the 3. Now we can use this identity to factor. The factored form would be a plus b, a plus b. Here a is 3b, so 3b plus bb is 1 in this example. Then we have a to the 2. What is a? A is 3b, 3b to the 2. 3b to the 2 is 9b to the 2. Raise this term to the power of 2, it would be 9b to the 2. Then minus a times b. 1 times by anything is itself, so 3b times 1 is 3b, so minus 3b. And finally we have plus b to the 2, b is 1, 1 to the 2 is 1. So this is the factored form of this expression here. And let me explain something here. In these brackets we have, as you can see, trinomials. And these trinomials, maybe you are thinking to factoring them because maybe you remember factoring trinomials, and maybe you think that We are not done. We have to factor these trinomials in the brackets. But the thing is that you cannot factor these trinomials. For example, in this first one, you cannot find two numbers that their product is 4, their sum is negative 2. Or here you cannot find two numbers that their product is 100, their sum is 10. And so you cannot factor these trinomials that appears in the second bracket of sum and difference of cubes identity. So we are not going to try to factor these brackets. And we leave the answer in this form. Now look at these two examples, a to the 6 minus b to the 3. First, let me remind you, a to the 3 minus b to the 3 is a minus b times a to ab b2. So we can factor this. First of all, note that a to the 6 is a to the 2 to the 3. b to the 3 is b to the 3. It's ready. So we want to use these identities for factoring this. By comparing with this, we notice that instead of a, we have a to the 2. So a is here a to the 2. So the factored form would be a to the 2 minus b is b minus b times y. A to the 2, but or a here is a to the 2. Raised to the 2 this would be a to the 4. Plus a times b, multiply this by this, a to b plus a to b, and finally we have b to the 2, which here is also b, so b to the 2. This is the factored form of this. Look at the next example. These type of examples appear in calculus courses. Let's try this. This is our a and this is our b. A minus b, so the answer would be x plus h minus x. If you want, you can put a bracket for this part, but it's really not necessary, so it's better not to put bracket for x plus h and write it as x plus h times by a to the 2. A is x plus h to the 2. Because we want to raise this to the 2, we have to put bracket. ab, x plus h times x. And I'm not going to write it as x plus h times x. I prefer to put x here. X times x plus h. The order of multiplication doesn't matter. And b to the 2, b is x to the 2. This is the factored form of that expression. But if you pay attention, in the first bracket you can simplify. X plus h minus x, this x with this x cancels, and we have only h. So we have h for the first bracket. If you want, you can put a bracket for h, but it's not really necessary. And for the second bracket, we leave it as it is. We don't want to do anything with the second bracket. If you like, you can multiply x in the bracket, but it's not necessary, so leave it in this form. And this is the answer of this question. Now look at these examples. X to the 6 plus 64. Let me again write down the formula. A to the 3 plus b to the 3 is a plus b times by a2 minus ab plus b2. The factored form of this would be, this is x2 to the 3 and this is 4 to the 3. So the factored form would be a plus b. A is this, b is 4. So x2 plus 4 times by a2. x2 to the 2 would be x4. Minus ab, multiply 4 by x2 minus 4x2. b to the 2 is 16. And this is the factored form for this expression. Look at the next example. X to the 9 plus 1. X to the 9 is basically x to the 3 to the 3. And 1 is 1 to the 3. So immediately we know that this is a, this is b. So based on the formula, we can factor it in the form of x to the 3 plus 1 a plus b. This is a, this is b. A plus b. Then a to the 2. x3 to the 2 is x to the 6. ab, 1 times x3 but minus x3. b2, 1 to the 2 is 1. When we get to here, we notice that we have something that fits with this formula again. a3, b3, x3, 1 to the 3. So we can factor this bracket again. Based on this identity again, for this part, we can write this as x plus 1, a plus b, a is x, b is 1, times by a2, x2, minus, focus in here, minus ab, minus 1 times x minus x, plus b to the 2, 1, and leave the second bracket. This is the factored form of this expression. Look at these examples. x4y, xy4. The powers are 4. They are not related to 3 in any way. But we notice that we have common factor between x4y and xy4. So we think to factoring first common factor, then maybe we can use the sum or difference of a squares identity. What is common factor between x4y and xy4? X is common between them and y. So we can factor xy from these two terms. If we factor xy, then we have xy times y. When we factor xy, then from the first term, if we divide this by xy, y with y cancels, x4 over x is x3. If we divide this by xy, x with x cancels, y4 over y is y to the 3. Now, this equals to xy times y. For this, we remember the a to the 3 plus b to the 3 identity. Don't worry, gradually by doing more and more example, you can memorize the identity. What was the identity if you remember? a3 plus b3 is a plus b times a2 minus ab plus b2. So, based on the identity, x3 plus y3 would be x plus y times a2 x2 minus ab xy b2 y2. Look at the next example. 2 to the 3x minus 216. We have to make this in this form to fit with this formula. a3, but we have 2 to the 3x. But we know that we can write 2 to the 3x in the form of 2 to the x to the 3. Because power multiplies by the power, we get the same thing. Now we attention that this is a. A is this bracket. Minus 216 is 6 to the 3. So this is a and this is b. Based on the identity, but attention between them is minus, so we have to use basically this identity. When here is minus, here is minus, here is plus. So the factored form would be a minus b, 2 to the x minus 6, times by a2, a to the 2, 2 to the x to the 2 would be 2 to the 2x, plus ab, this times by this, 6 times by 2 to the x, plus 6 to the 2, b to the 2, 6 to the 2, 36. And this is the factored form of this expression. This was a little challenging. This is again something that can come up in the calculus course or other advanced math courses that you can see questions challenging like this. I hope by watching this video, now you are a little familiar with sum and difference identities, how we can use them for factoring expressions. If you like this video, please subscribe in my channel and see you in the next videos.